RAM is primary memory or temporary storage. This is called as random access memory. In order for a program to run, it needs to be loaded into RAM first. The data or the program is stored on the hard drive, and from the hard drive it is loaded into RAM. And once it is loaded into RAM, the CPU can access the data or run the program. Now a lot of times if the memory is too low, it might not be able to hold all the data that its CPU needs. And when this happens, then some other data has to be kept on the hard drive to compensate for low memory. So a set of data going from the RAM to the CPU, it has to do extra work by going back to the hard drive. When this happens, it slows down the computer. So to solve this problem, all you need to do is increase the amount of RAM on the computer. And by increasing the memory, all the data can be loaded into RAM without a need of constantly accessing the hard drive. And a result, a faster performing computer. Random access memory. RAM requires a constant electrical power to store data. And if the power is turned off, then the data is erased. RAM is stored on the motherboard in modules called DIMMs. These DIMMs come in different memory sizes. Today the range is anywhere from 128 MB to 4 GB per DIMM or more. RAM types. RAM also comes in different types, such as dynamic RAM or DRAM. DRAM is memory that contains capacitors. And because it has capacitors, it has to be refreshed often. SRAM, synchronous RAM. This memory uses transistors and does not have to be refreshed, unlike DRAM. And because of this is much faster than DRAM. And it is also very expensive. An example for SRAM, memory cache level 1 and 2 that is used by the CPU. SDRAM, synchronous dynamic RAM. The other memory is called SDRAM, which stands for synchronous DRAM. This type of memory what is used today in RAM DIMMs. SDRAM and DRAM is basically speed. The older DRAM technology operates asynchronously with the system clock, which basically means that it runs slower than a system clock, because its signals are not coordinated with it. But SDRAM technology operates synchronously with the system clock, which is why it is faster than DRAM. All the signals are tied to the system clock for a better control timing. RAM speed. SDRAM is rated at different speeds. For example, a stick of SDRAM could be labeled PC100. PC100 means 100 MHz equals the speed at which it operates, which is 100 MHz. And since SDRAM only comes in 64-bit modules, it has 8-byte wide bus. Because 64/8 equals 8. So the figure of the total bandwidth of the PC100 x 8 bytes equals 800 megabytes per second, megabyte per second. So the total bandwidth of PC100 equals 800 megabytes per second. SDRAM PC133. So an SDRAM module labeled PC133. If you multiply 133 with 8, you will get 1066 megabits per second. So the total bandwidth for PC133 is 1066 megabytes per second. Random access memory RAM. As technology increased, the process and bus speed gotten faster. A new way of technology was developed to keep up with the faster speeds of computers. This newer technology was called DDR, double data rate. And that's basically what DDR does. It sends double the amount of data in each clock signal compared to non-DDR RAM. SDRAM, DDR RAM. Non-DDR, SDRAM, or single data rate RAM uses all in the raising edge of the signal to transfer the data. But DDR uses both raising and following edges of the clock signal to send data, which makes DDR twice as fast. DDR also labeled differently than non-DDR, single data rate RAM. Instead of including the clock speed in its name like PC133, where 133 is equal to the clock speed, DDR uses the total bandwidth instead. For example, a DDR DIMM is labeled PC2700. The 2700 is not the clock speed, but it's the actual total bandwidth. The clock speed for PC2700 is 333 MHz clock speed. 333 MHz by 8 bytes equals 2700 megabits per second. The other example is PC3200. PC3200 has a clock speed of 400 MHz. So 400 MHz by 8 bytes equals 3200 megabits per second. DDR2. A new technology that has succeeded DDR is DDR2. DDR2 is faster than DDR. It allows for higher bus speeds. It uses less power than DDR. A DDR2 has 240 pins compared to a 184 pins on DDR. Some examples of DDR2 are PC2-3200 and PC2-4200. And the latest RAM technology is the called DDR3. DDR3 twice as fast as DDR2, with the bandwidth of over 12,800 megabytes per second. Like DDR2, a DDR3 DIMM also has 240 pins. But the bottom notches in the DIMMs are different places. So you can put a DDR3 DIMM in the RAM slot made for DDR2. In fact, motherboards are made to support a certain type of memory, so you can mix DDR1, DDR2, DDR3 on the same motherboard. Some examples of DDR3 is PC3-8500, PC3-12800. RDRAM, RAMBUS Dynamic RAM. Another type of memory was called RDRAM, which was developed by RAMBUS Inc. And they developed RIMM, Rambus Inline Memory Module. RIMMs have 184 pins and look similar to DIMMs, with the exception that the bottom notches are located at the center of the module. In 1999, RIMMs was breakthrough in the speed of memory, but has quickly fallen behind due to the advancement of technology in DIMMs. When RDRAM debuted in 1999, RDRAM speed was at 800 MHz, which was considerably faster than SDRAM's. SDRAM speed was 133 MHz. But even though it was a lot faster than SDRAM, RDRAM only had a 2-byte wide bus, but SDRAM had 8-byte wide bus. So if you multiply the speed of RDRAM, which was 800 MHz, times the bus width, which was 2 bytes, you will get a total bandwidth of 1600 megabytes per second. 800 MHz by 2 bytes equals 1600 megabytes per second. RIMM technology was designed to work with a continuous signal, which means that all the other memory on the motherboard must be used for RIMMs to work properly. And if other RAMs are not available, then a user can install CRIMM, RAM, or Continuity RIMM, Dummy RIMM, to ensure continuity in all the memory slots. Dual channel mode. To meet the higher demands of faster processors and memory controls, a new technology was developed called dual channel mode. Dual channel mode requires a pair of identical DIMMs installed on the motherboard, which allows the memory controller the ability to communicate with 2 DIMMs simultaneously, which increases the speed of accessing the memory. In order for dual channel to work, the motherboard must be equipped to work in dual channel mode, and the memory DIMMs must be identical to each other in speed, size, and features. Then the DIMMs must be inserted into the motherboard in a specific slot configuration in order to enable dual channel mode. Typically, the memory slots will be color-coded to help assist in identifying where the DIMMs should be inserted. For example, you will have some dual-channel memory slots, so in order to dual-channel to work, you need to install a pair of identical DIMMs in the slots of the same color. In this case, we put a pair of DIMMs in the red slots. ECC Memory. Some RAM modules have ECC, which stands for Error Correcting Code. And what it does is that it detects if the data was correctly processed by the memory module, and makes a correction if it needs to. You can tell if a RAM module has ECC by counting the number of memory on the module. The above RAM has 8 memory chips, black. And a standard non-ECC DIMM, it will have 8 memory chips. But in a ECC module, it will have 9 memory chips. Most memory modules today are non-ECC. And this is because of the advance in technology that has minimized memory errors, and has made non-ECC RAM more stable. Typically today, ECC memory is mostly used in servers, because servers need to be up and running at all the times. And using ECC memory is just an extra precaution to guard against any memory errors. If you understand this explanation, comment, like and share. Subscribe to Smart Cherry for more knowledge.